operations.
Hello everyone, this is Socrates Kartakis, an MLOps specialist for AWS. In the last video, we saw the introduction to MLOps, and we gave it the definition. MLOps is the combination of people, processes, and technologies in order to productionize machine learning solutions efficiently. In this video, we will cover the first two pillars of people and processes. We will see how the data science teams used to be structured in a business, the key personas, the key processes that they need to follow, and how they need to collaborate with other teams in order to productionize solutions. But let's deep dive. In different customers, we have seen four main patterns of how they structure their data science teams. The first pattern is about the functional one. In the functional one, the data science teams used to be spread across different business units. So each business unit has its own data science team. The second pattern that we have seen is that one data science team will cover the needs of all the different business units. In that case, all the different business units needs to request different ML use cases, different problems to be solved by the data science team, and they need to resolve this issue. Normally, the most common pattern is a hybrid approach between the two, functional and centralized. Why is that? Because we can have a centralized data science team who is responsible to standardize the way that the data science used to develop the ML use cases. And then we have different data science teams in different business units that they have domain knowledge and they know how to optimize their models that they create. Lastly, we have another approach, the decentralized approach, that we haven't seen that quite often in different customers, and this is because we have just data scientists here and there just to cover on-demand needs. But let's see now the main personas. We have split the different personas to different teams. The first team that we need to check is the advanced analytics team. Advanced analytics team is responsible for data lake or data mesh solution that a business might have. We have two main personas there, the data engineers and the data owners. Sometimes we have also some roles that we call them like data stewards, but we will keep that out of scope for the time being. Data engineers are responsible to ingest data from multiple data sources, create ETL pipelines, clean the data, curate the data, catalog the data, and make them available to other teams. For example, for the data science teams, what they need to do is to join multiple data sources, create the historical data, and have them available for them. Data owners, from the other side, they're responsible for the data access control. They're responsible to give access to specific teams based on their rules and compliance that they follow in the business. The next important team that we have is the data science team. In the data science team, we have two key personas, data scientists and ML engineers. Data scientists are responsible to create their notebooks, create the research, and make the best model that they can in order to solve a business problem. Then they need to collaborate with ML engineers, that their background is more around software engineer, but they can understand data science, in order to upskill and in order to bring the quality of the code to a certain level to be production ready. That means that these two personas, they need to collaborate together to create production ready ML use cases. So the solutions. The next team is the platform team. In the platform team, we have different stakeholders that are responsible for the whole platform strategy that the business needs to follow. Specifically, we have security SMEs who are responsible for the end-to-end security of the infrastructure on the cloud to make sure that the data cannot leak, they have the right networking restrictions, etc. We have the architects who are responsible to link all the different pieces together. Of course, this is not just for ML, it is for data, for networking, for other applications. And in MLOps, we have a new role. This new role is the MLOps engineer or admins. This role is responsible to standardize the way that the models will go to production. Specifically, they need to standardize the way that the repo should be structured and the CI/CD pipelines will execute the different commands. They are not responsible to create solutions, and to differentiate a little bit compared to the ML engineer, because there is a confusion there sometimes. MLOps engineers are responsible for creating the boxes of automation, of automatic deployment, while ML engineers are responsible to create the content together with the data scientists and whatever will go to production. The next important team that we have is the business team. In this team, we have the product owners of machine learning solutions and the consumers of the machine learning results. The product owners are responsible to track that their solution can solve the business problems, and they are aligned with the business KPIs. This can be sometimes lead data scientists or owners of a specific business unit. On the other side, the consumers are responsible to use the solution and to return back to the product owners with feedback about how the solution works for them. For example, let's imagine that we have a team that builds, like the retention team that builds the churn prediction for their customers. In that case, the product owner needs to get the feedback from the marketing team that is responsible to use the churn predictions in order to drive their campaigns. For another type of customers, we have one more team, and this is the risk and compliance team. We found these teams mostly in very restrictive customers like in financial sector or other verticals, and they are responsible to audit how the different models has been created. For example, what type of data we used in order to create these models, what type of artifacts, and if all of them follow exactly the same policies as has been standardized by the business. Here in Europe, we have also AI Act, and this is something that they really care about. Okay, let's see step by step the life cycle of a machine learning problem and how the business defines all of them. First of all, we have business stakeholders from different departments that they say, oh, I have all these different business problems. And what they do is they talk with the lead data scientists or product owners, and they try to identify which of those business problems can be solved by using machine learning. Together, they define the KPIs and success criteria of these solutions. They define what are the dependencies across the business, and also they define what is the expected outcome, the return of investment, for example. After they have cleared this list, the next step for the lead data scientist is to go back to his team and to discuss with them what is the effort that they need to spend in order to build such a solution for each problem, let's say. They need to create a data wish list to make sure that they have access to this data. And they need to check if they already have implemented that somewhere and they have a template that can help them to productionize that faster. By having defined those, the lead data scientist needs to collaborate with data owners. They need to check if they have available data, if there is any restriction because of confidentiality, or if they can share the data with the data science team. After all these different processes, the outcome is to select the right business problem that they can solve in the time frame that the business requires, and they have access to all the necessary components, like the data. The next step is to start a long life cycle. This starts, of course, with the data. The data engineers, they need to ingest the right data on the cloud. Then they need to process the data, like check the quality of the data, if they have missing values, for example, improve the quality of the data, and catalog the data. Then they need to create ETL pipelines. That means the data scientists, they don't expect to receive 100 different tables across different business units. What they want to have is just a single table with historical data, or a single folder with images or PDF files, depending on the ML use case. After we have the first snapshot of data prepared, the next step is to send this data to data scientists. The data scientists, what they do is first they sample the data and they start exploring them by creating new features. Feature engineering is what takes most of the time for the data science to create, because this is what will improve also our model. So after they have created the first few features, the next step is to create and fine-tune the baseline models. After we have built the first baseline models, the next step is to evaluate the model and to make sure that the model can solve the business problem. And this is what we call as POC or POV sometimes. Of course, this process is something that we need to repeat continuously, and the data scientists used to improve continuously the model by starting again by data sampling, new features, and fine-tuning the model. If we prove that this specific solution can be productionized, the next step is to move the model into production. How can we do that? The data science and ML engineers, they need to create automatic workflows that we saw in the last video, the ML pipelines. These ML pipelines will do pre-processing, training, post-processing, and it will generate a new model. This new model will be moved to a centralized place that we keep all the versions, and the auditors are able to audit, and even the lead data scientists are able to check the performance. Then automation will take the model from there and it will deploy into production that we will be able to serve other business units. And a continuous process is about model monitoring. We have a model up and running into production, but the story does not end there. What we need to do is to continuously monitoring the performance of this, and if we have reduced performance, then we need again to start the circle and to check why it does not work. This is the complete life cycle of machine learning, but one key note is that not all the machine learning solutions from POCs will be moved to production. This is because in the first phase, we understand if machine learning can really solve a problem or not. For example, we have seen customers that sometimes they have performance, let's say, around 60% or 50%. In that case, it is better to throw a coin and to get a decision. It's exactly the same. So it does not make sense to move the solution into production. But let's see how everything is linked together. The first team that we have is the platform administration team. In this team, they are responsible to create the different platforms for the different users in order to start using the cloud. That means that they need to provision infrastructure, new accounts, give access to the users to these accounts, and of course to give access to data. But where do we store the data? We have the layer of the data. In the layer of the data, we have the world of data lakes, data mesh, where the data engineers, they use to ingest data, curate data, prepare data, as we saw in the previous slide. At this layer, we have the data owners that they share the data with other business units, but also we have business stakeholders that they use to access visualization dashboards. Like QuickSight, you can have one single view that you can see all the data and the results from there in order to drive decisions. The next piece of the puzzle is the experimentation environment. In the experimentation environment, we have the data scientists who are responsible to create their POCs, POVs, and to prove that machine learning can solve a business problem. The next step is to start productionizing everything. So in that case, we have an environment for model building. Over there, we build the automation to do pre-processing, training, post-processing to generate models. And we have a restricted environment of model testing and model deployment that everything happens automatically. In model building, we have data scientists and ML engineers to collaborate together to create the new models, of course by using CI/CD pipelines only, as we will see in the technology pillar. And the model testing and deployment environment, nobody needs to have access and everything is based on automation. On top of that, what we need to have is a layer of ML governance. This is the ML control tower, as I used to call it. And what we have over there is the centralized place that all the artifacts, all the models used to be stored, and the product owners or lead data scientists or auditors, they have access to check what is happening with the results of the solutions. And what are the artifacts, either data or other artifacts that were used in order to produce these solutions. And we have also the model approvers. At this place, we need to be able to capture all the versions of the models. We need to capture the monitoring alerts and to share those with the right stakeholders. And this is the complete picture on the cloud. But let's see how all these different teams are linked together. In order to productionize machine learning efficiently, we need to standardize the MLOps platform. And we have seen two different scenarios around this. The first scenario is the factory scenario. In the factory scenario, we have each business unit that it has its own data science, advanced analytics, and platform team, and they decide their own way that they will productionize machine learning, or they decide what are the different components that they will use, what are the different tools. This has a problem because different teams, they work in silos. You cannot reuse really solutions from another team. And you cannot have collaboration across the different teams, even if they have standardized the different solutions in the different business units. What we suggest to the customers is to create ML Center of Excellence. ML Center of Excellence is a centralized team that has people from all the different business units. It is not a formal team, but a theoretical team, let's say. And we have data scientists, advanced analytics, and platform team from different business units to co-agree and decide the common strategy around MLOps platform. This is the way to go and the way that we recommend. Why is that? Because if you have a standardized MLOps platform across your whole business, then you improve reusability, you make sure that all the different teams, they follow the same security standards, and overall, you are able to enable collaboration across your business and to have speed to value that we want to achieve. Okay, what we have seen so far is people and processes, and we deep dive on how we structure the data science teams. Then we saw the different personas and the main process that we need to follow and how everything is linked together. And lastly, we discussed a little bit about Machine Learning Center of Excellence. In the next video, we will focus on technology. Until then, stay tuned.